Hi everyone. So today we talk about how Graph X AI can be used to combat fraud in fintech and insurtech sectors. This is today's agenda, but let's go through the presentation. I'm Alberto De Lazzari, Chief Scientist at LARUS. So we started our partnership with Fujitsu in 2019. So the common idea is to show the potential of Graph AI, or better XAI, to drive business decision-making processes. And so we started this partnership with Fujitsu to show that. But now I will leave the stage to Surya. He will talk about himself, Fujitsu Laboratories, Deep Tensor, of course, and he will give you an overview of fintech and insurtech sectors.
Great. Thanks, Alberto. Again, this is hello, everyone. I'm Surya. I'm the Director of Marketing at Fujitsu Research of America. We are the research arm of Fujitsu Ltd. And my role at Fujitsu Research is to bring our technologies to market through business incubation and working with our customers and partners such as LARUS, and also on co-creation initiatives. So moving on, so let me take a few minutes to introduce the Fujitsu and also our AI research. So at Fujitsu Research, we have centers all over the world, including in Japan, United States, Europe, and in China. In AI, we have several ongoing projects, including new advances in machine learning, for example, AutoML. We also have a team focused on bringing AI to enhance human and societal areas through projects on knowledge graph and semantic understanding. You all may have heard of Fugaku, currently the world's fastest supercomputer. We are using our expertise in supercomputing and quantum computing to further enhance and develop new AI applications that can leverage our advantages in high-performance computing. Our overall goal for our AI projects is to aid in the transformation of society, experiences, and industries. And to this end, we are very active in the AI ethics community and are focused on building AI systems that can be trusted and with explainability built in from the ground up. Let me now introduce a deep tensor. So in machine learning for graph data, the conventional approach is to take the graph and break it down into subgraphs. You then look for a pattern of interest, for example, fraud, in the subgraphs. If you find the desired pattern, you mark it with, let's say, a 1, and an absence of a pattern is marked with a 0. These bit strings that represent a feature are then used to train the machine learning model. The problem with this approach is that you may end up missing important features in the larger graph as you're focusing on the subgraph at a time. Additionally, the ML model may not have sufficient accuracy. So Fujitsu Research has developed a deep tensor technology that uses automated approach for local and global feature extraction. We also have the ability to pinpoint which part of the graph contributed to the prediction results. We use 2 techniques as part of this effort. One is called node index shuffling, and the second is transformer. Let me explain this in greater detail. So the next slide, Alberto.
No, sorry.
Okay.
This one.
Okay, so in terms of in node index shuffling, so we take the graph data and convert it to a tensor by applying node index shuffling method to get the various tensor expressions. The tensor is a higher level mathematical representation of the original graph. We then take the tensor representation and convert that into a vector representation to build the machine learning model. This enables us to extract complex features in the graph, like loops. As many of you know, transformers in recent years have become a dominant architecture for natural language processing, surpassing alternative models such as recurrent neural networks in performance for tasks both in natural language understanding and natural language generation. To extract local features of the graph, we use an adjacency-restricted transformer, and we apply another transformer to understand the global features of the overall graph. So by combining both the node index shuffling and transformers, we are able to develop a highly accurate ML model of the graph, and through feedback iterative process can constantly improve the accuracy of the results. So let me now take a look at some of the common problems in both fintech and insurtech, starting off with fintech. So in the fintech area, so you have, it's a major problem. And overall, I think it is expected that about 1.8 billion euros are lost in fraud. And 80% of these fraudulent transactions are card not present transactions. That is for online payments. And the number of fraudulent transactions has increased over the years. And this is a huge problem. Going to the next slide. And so, yeah, you can go to the next slide, Albert.
Sorry. Okay.
So in the credit card fraud patterns, so some of the common fraud patterns in Insurtech are circular flow of money is a very common problem. And in the circular flow of money, what happens is it's a very common type of fraud, and it is very simple to detect using a graph, regardless of the length of the path. We can use connected data to rank transactions just using a simple risk propagation algorithm, for example, propagating the risk connected to suspicious merchants, and using fraudulent transactions to track the transactions that way. But there are other types of fraud that can happen in fintech that we also want to care about. So one of the, go on to the next slide, please.
Yes, it's this one.
So some of the issues in fintech are, in general, looking at the validation process of a transaction. We just take a look at the discrete data while we need to explore not just the single point, but a wider range of information and connections. This is only possible if you use graph-based technologies and algorithms and can improve the process using graph-based validations, both in real time and offline. While we are facing an unbalanced data set, the classification task is not always feasible, but we can use graph algorithms to do automatic labeling of data that is not already labeled. We can use graph structures not only as a base for classification, but also to score credit cards as potentially fraudulent or not. Explainability and in general transparency is a very important topic, which when we develop AI systems that can impact a human. In extremely regulated contexts like in banks and financial institutions, we need to implement a trustworthy AI system, and we need to be sure why the algorithm gives us a negative answer instead of a positive one. Transparency is a necessary condition, we believe, for AI adoption in these contexts. So now looking at graphs, let's uncover and use hidden connections to improve our graph AI algorithms. We can use network science algorithms to produce outputs that will become inputs for AI systems. We can use communities-related information or scoring attributes derived from centrality algorithms and so on. We can just simply learn directly from the graph structures, uncovering unknown relationships and connections between entities. We have a lot of possible ways, therefore, to improve our ML process using graph-based AI algorithms. So now moving on to Insurtech. In Italy, according to the Institute for Supervision of Insurance, in 2018, there were 42 million insured vehicles and nearly 3 million claims, of which over 600,000 were potential cases of fraud. So fraud in insurance sector is a very complex issue due to the many factors, and in one of these are the laws governing claims. The more accurate and quick the analysis is of a potential fraud, the lower is the chance of losing money by the insurance company. So the size and scope of the problem puts an enormous burden on human analysts, requiring automated solutions to address the problem. And as I said in the previous slide, fraud detection teams need to focus on the important claims, reducing the number of false positives as much as possible. They also need to be very effective rules to match both already known fraud and new ones. So let's look at 3 common fraud schemes. So over-reporting is one of the most common fraud. Inflating the value of equipment stolen or including old damage as part of a new claim are quite common behaviors. The second is that of geography. In most countries, insurance rates are different according to the geographic areas. For example, in Italy, small cities in the north are cheaper than big cities or in the southern areas. So rates are correlated to the risk of having an accident, and in general, the number of claims declared year by year for a specific area. So using someone else's address is a common way to avoid higher insurance rates. And the last one for sure is another interesting scheme, and it's tightly related to colluding groups of subjects. They create fake accidents between themselves and keep changing their roles and recycling participants that way. So So what are some of these issues and how can we improve the overall process? So time and resources are very important aspects of the entire process when managing a claim. Rules are sometimes too simple or poor and generate too many false positives. The real risk behind that is to have a rule that is completely ignored by the fraud department. The cost of processing all the alerts produced by the rules become higher than the money lost due to real fraud. The key point is to implement an efficient and effective way to discover and analyze potential cases of fraud. When I talk about effective fraud detection system, I mean to be able to detect changing behaviors of the fraudsters. The system must adapt to new fraud schemes and uncover unknown connections between potential colluding groups of subjects. Explainability is a key feature to improve the detection system over time and let the user have full control of the learning process. So how can we use graphs and graph algorithms combined with AI to detect fraud in Insurtech? So community detection algorithms can play a significant role in discovering groups of fraudsters. In general, what we have found is groups of tightly connected subjects recycling roles in different accidents where they are all participants. So within these communities, central subjects have a tight correlation with high risk scores coming from a unified Italian archive of claims, for example. In general, these subjects are potential organizers of a colluding network. So to recap, there are many examples of fraud in fintech and insurtech, but by leveraging graphs and graph AI technologies, enterprises can not only detect fraud and take proactive approach to preventing fraud from happening in the first place. So let me now hand it back to Alberto to discuss Galileo XAI, which is a solution to this problem, and also show you a very exciting demo. So Alberto, back to you.
Thank you, Surya. So let's take a look at how Galileo XAI is. So we think that this graph data science platform for explainable AI is dedicated to business domain expert and decision maker who want to extract new knowledge for their data. So the idea is to connect data silos and allows the implementation of advanced and predictive analysis on linked data, on strongly connected data. And we use network science algorithms and pattern matching and graph AI, or better, graph XAI, because we believe that the explainability part is very important, as Surya already said, in certain sectors. And of course, graph visualization is another important feature of the product. Galileo XAI is modular by design, so you have a core foundation, core component, and you have different models you can combine according to your needs or according to the problem you want to solve. We have already prepared a set of modules or components for two vertical solutions. The first one is the fraud detection one. So the demo will about this vertical solution, but we also have a vertical solution for IT asset management. And another important part for us is, of course, the integration part. And the last connectors in particular are LifeRay, Salesforce, and SAP. So let me share my screen again, and let me show the demo. Okay, so let's start with the demo. So we imagine that we can create a pipeline. We start from the connections. So we want to define our model. We want to import our data, put the things together, and create a connection between our entities. And then the second part is the insights part. So we want to analyze data. We discover new insights. We find significant patterns, and we want to check these patterns periodically. We want to be the platform notifies us once a pattern is discovered. Again, then the next step is the knowledge step. So we want to try to understand the overall structure of the network. So we want to apply different algorithms. We want to create our own pipelines or recipes. So combine different algorithms together in order to understand graph structures, network dynamics, and underline important nodes in the network, for example. Then what we want to do is the prediction part. So we want to apply graph AI to our data in order to improve our algorithms, the outcome of our algorithms. We can do two things. We can directly learn from graph structures, so use graph native AI algorithms like the tensor, but we also can use the knowledge part, so the graph analysis, and use indicators or measures we derived from, I don't know, a community detection algorithm or a centrality algorithm, and use this as inputs for our graph AI algorithm to improve the outcome. But as Surya said in the previous slides, it's very important, the transparency part. We know that when we use AI systems, AI algorithms in certain sectors like the Insurtech and Fintech sectors, the outcome of the algorithm can have a huge impact on a human being. So the user has to have the full control of the algorithm. He has to understand how what are the features that contributes more to a specific outcome. I want to know here why a subject could be a suspicious subject, or a credit card is a potential suspicious credit card. So I have to understand how the learning phase works. But let's go through the demo. So we start with the dashboard. Here we can create our own charts. We can combine ciphered queries with a specific type of chart. In this case, I'm putting together ciphered queries and histograms. So I can use in different ways. I can create KPIs for the end user. I want to monitor suspicious subjects or an accident in a certain region and so on. But I can also create histograms, in this case, for graph structures analysis. Here we are talking about subjects involved in accidents. So we are in the Insurtech sector. So we have subjects involved in accidents or related to claims. And what we want to take a look, for example, is how subjects are connected through common accidents. And what we can see for in the first chart, for example, is that most of the communities are composed by 2, 3, or 4 subjects. At least in Italy, it's quite common to have few subjects involved in an accident. And then I can, for example, take these communities and take a look at the most important subjects in these communities, in these subgraphs. Because when we have, for example, a lot of connections between the same subjects, so they are involved in different accidents and they're exchanging roles, there is this recycling of participants scheme. We want to also understand if there is a central node. Maybe it could be the organizer. And what we see is that the centrality, the value of the centrality of a specific subject in these communities, in these suspicious communities, is related to the scores that comes from the IVAS, so the central institution for supervision of the accidents, because this organization has its own scores to subjects and vehicles according to their history, their past accidents. And we see that the scores from this central archive are quite tightly correlated with the centrality. So then we can create our own rules. So we want to, for example, periodically check subjects with high rank, or see maybe subjects participating in accident with direct payment, and so on. So it's very useful because you can define your own rules, check patterns, and then once a pattern is matched in the graph, you have, of course, your own notification. You can take a look at the notification. You can assign the notification to yourself, and then you can take a look at notification. For example, here I can see that this subject is it's like to be a suspicious one, because it's related, it's connected to different accidents with high risk, and he has different roles in different accidents. And I can also put a note on my notification. In this case, for me, it's significant and I need further investigation. And then I can also save my analysis, because maybe I want to share with other guys, with my colleague of the same team. And what we can see here, we have two communities where we have subjects that have, you can see also here, just let me zoom the node. This is the rank of this node. This node is involved in 3 accidents with the same role, but the accidents are scored as high risk accidents. And so maybe here we have probably a group of fraudsters that try to create fake accidents. Here we have other 2 subjects with a higher rank, changing their roles within this community. So we can use this information, of course, to improve our prediction algorithms. We do this using the graph data science feature. Here we're using the graph data science library, Neo4j graph data science library, so we can define our projection through simple Cypher queries, or maybe just choose the nodes we want to project and all the relationship. Maybe we just only want to take a piece, let's say a piece of the graph, and then apply the algorithm. Or of course, you can recall already defined projections. You have here, for example, the number of nodes, relationships, and the nodes and the relationships that are used to create, were used to create the projection. And then you can apply your algorithm. You can choose here the algorithm you want to apply. So what you can do, let's say you want to create so we want to write the degree centrality. So we can run the algorithm, apply the degree centrality. We have the results. So we have all the node properties written to the database. And as I said, we can use this information to as an indicator for scoring our subjects or our accidents. And we can create a pipeline, so combine algorithms to, of course, find interesting subjects or accidents. The point is that we want to the end user to be effective and efficient when doing his job. One of the most important issues are false positives. So the idea is to reduce the false positives as much as possible, and let the user to be able to focus only on the important subjects or important accidents, and also give the user very easy and efficient way to explore data and understand all the connections related to subjects and accidents in this use case. And then we have the final part is the graph AI part, and also the explainability part. So here in this case, we can, of course, define our own projection. So we want to extract maybe just a part of the graph and learn from that projection. We define the classification property. Maybe we already have labeled data, so we want to learn from the set of the labeled data. Here we have the all the configuration for the algorithm for deep tensor, And just let me recall already prepared model. In this case, we can save different models, and we can compare the models and see what is the best one, because we want maybe just use a specific model for the production, or we want to create different models to find different things. Could be, of course, suspicious subjects with a specific subgraph, using specific subgraph with specific attributes and indicators, or maybe specific suspicious vehicles. So we want to use another projection with other attributes and so on. So we can manage different models. We can recall here the query we used, but also all the information for the previous training. And then we can, we'll skip to the explainability part. So I want to understand, just let me go select the right model. So what I want to do is to understand why a specific accident as an outcome as a suspicious accident. So in this case, this accident has a predicted class of 1, so it means it's a suspicious accident. And what I can see is that we have these 4 nodes, so the accident itself and these 3 subjects, they have a low contribution in defining this accident as a suspicious one. But if I take a look at this subject, it seems that this subject has the highest contribution for the outcome of this accident as a suspicious one. And if I take a look at this subject, I can see that is involved with different roles in different accidents. So the point is that here we have the subject involved in many accidents with different roles, and the accidents themselves are risky accidents. So for sure, this node has the highest contribution in predicting the accident as a suspicious one. In this case, what we can do then is to take a look at the results of the deep tensor with its explainability part, and understand if we are if the algorithm is learning correctly from the graphs, the subgraphs. And of course, we can then adjust, so we can understand if he is learning correctly, and then if not, we can go back, change our projections, do other analysis with the graph data science feature, and rerun again and compare the run and the explainability part, and see if we are doing better or not compared to the previous run. So in general, this is iterative process in order to improve the outcome as much as possible. And then we can use the learn model in the rule feature. So we just don't want to use any, let's say, static fixed pattern, but we want to integrate the use of our model. So the rule will be, okay, I will take all the new accidents or the new subjects or any changes in the graph, and I want you to predict if this accident now is suspicious accident or not. So the new alert will benefit of the graph machine learning part, and not only for the fixed rules, because the point is that using fixed rules is okay. You can get insights, but they are not able to cope with the fraudsters. They in general, fraudsters are able to change their behavior in order to be, or to let's say, behave as normal people. And so it's not so easy with a fixed rule to do this. We need something that is able to learn from network dynamics to connections. And so the best way to do is to put together to use the graph AI part for sure. So we can put this into our rules and improve our rules in order to have less false positives and to focus just only to real use cases. Because one of the problem is the quality of rules. Sometimes we have rules that are too poor. The lack of context. They are too poor rules. The rules themselves are not able to find useful use cases. So you end up to ignore the rule because you have too many false positives. While the point is to be as much efficient as possible in order to focus just only the use cases. You really need to take a look, understand, and focus only on this. So this ends the demo. So I hope you enjoyed. Thank you so much, and thank you again.